Hello, and welcome to today's American Machinist webinar titled AI-Powered Machining, Optimize, Automate, Excel, sponsored by DELMIA Machining. I'm Robert Brooks. I'm the editor and content director of American Machinist. Before we begin, let me explain to listeners how you can participate in today's presentation. First, if at any time you encounter audio difficulties or the slides are not advancing, simply hit the F5 key to refresh your webcast console. If you're running pop-up blocking software, you must disable it to view the webinar. If you have any technical difficulties during today's session, please press the question mark help button in the upper right corner to receive assistance to solve common issues. This webinar technology allows you to resize the presentation by clicking the maximize icon in the upper right corner to enlarge the window. We welcome your questions during today's event. To submit a question, simply type that question into the window marked Ask a Question on the left side of your screen, and then hit the Submit button. We'll answer as many questions as possible during the Q&A session that will follow the main presentation today. But please feel free to send in your questions at any time, and we'll add them to the queue. Be sure to check the Resources tab on your console for additional information provided by our sponsor, DELMIA Machining. Also, please know that today's presentation is being recorded, and it will be available on the American Machinist website within the next day for you to review. And you'll be notified by email when the archive is available. When the webinar ends, please take a moment to complete the feedback form that will appear on your screen. Now I want to welcome our speaker. Dominique GALMEL is the Portfolio Director for Machining and Additive Manufacturing with Dassault Systèmes. For more information about Dominique, please check out the Speaker Details tab on your console. Now, welcome, Dominique. The floor is yours.
Thank you, Robert. Hello to all the audience, and thank you for joining our talk today, which will be centered on the artificial intelligence on machining and how it can increase, automate, optimize the performance overall of NC programming, but also machining operations on the shop floor. So the session will be going through first of all some couple of challenges and what are the topic around the AI, which is not AI for AI. You know, we are going to apply it to machining. So how it can guide also NC machine programmers. And we'll see later on what is our application is doing, and then I will go through some of the takeaways, and we'll have a few questions together with Robert over there taken. So first of all, is the CAM expertise at risk? What is the trends for the CAM users? The reality today is that in shop floors we see a lot of change, especially in the users, because expert users are retiring. There's a change in the generation. Former people are changing job, are moving away, changing activities with this retirement activity, and we get a new generation of people coming to the shop floor, and there are young people, good knowledge, but new expectations. They don't want to be bored about simple tools. They want to have friendly solutions. They are used to mobile activities. They are expecting the software to be more intelligent, to bring them help in their daily job, and they at some point they don't want to care about non-added value operations, let's say. They want more automation. So that's globally the trend in the shop floor that we are seeing. And the question is really, what is the impact at some point? So what is the risk? What are the risks for companies? Because behind the retirement of experts on the machining side, which is, this is quite a technical topic. There is challenges in the shop floor whenever you are having a machine running quite fast now, hard material. This is at some point really a difficult activity to do the right program. So losing the knowledge is really at stake. It's important for companies to be able to store and capitalize, centralize maybe sometimes the know-how of their experts, so that at some point their productivity will not be impacted by the change in the users. So to be sure that along the time of the experts retiring, the new generation will be able to take over, to get experience, and to keep at least the level of performance that is available as of today in companies, and then that can of course increase or get better use of the technology. So that's really the risks for company. And what is also coming, and what we're seeing also, is the fact that it's becoming sometimes difficult to hire young people, to let them come to these jobs that are quite technical. So it's really also the necessity for applications and programs and tools from the company to really be in line with the expectation of these new generations. So you should tell me, well, so what is the opportunity then for CAM vendors, and where these artificial intelligence applications or functionalities at some point today can help, can bring value to the end users, and what are the opportunities for CAM vendors and applications to the users? So the point is really to support, let's say, those new users. We have seen that there is this new generation of people. They maybe not familiar with those sometimes expert tools, which are quite maybe sometimes complete offers, a lot of background applications and a lot of functionalities sometimes. So that's really where it can provide assistance to new users. We'll see that how we can do that as of today. Second of the AI opportunity is really to, and maybe it's not related totally to the AI capability, but it's a complement to the fact that this expertise in terms of the knowledge is going away with the retirement of people. It's the capitalization of the knowledge and the maintenance, let's say, of the future machining performance. To have expert knowledge, keep the expertise of the knowledge, store it into an environment that can be easily reused, and apply it also, because at some point storing this knowledge is one thing, but the second point is really to be able to reuse it. And the point here is really to have both capabilities. So at some point, the opportunities are becoming quite wide, and this is the beginning, of course, for technical solutions like CAM programming to use all these new techniques, AI, but also knowledge management. But there's really some nice opportunities, nice possibilities to increase the performance of the NC programmers, to be more efficient on the shop floor, to keep the efficiency, let's say, on the shop floor. So let me show you a little bit of some examples that we can have for this topic, how the AI can guide, NC machine programmers, because this is what we would like to leverage as of today. What is the capability of artificial intelligence in the context of machine programming? First of all, a little bit of a introduction, let's say, or positioning of this intelligence artificial, which is the topic is not to replace anyone. Our idea, and I think this is a global theme overall in our company. We don't want to replace people. We want to let them, be more efficient and be, let's say, concentrated on added value actions. So that's really the point. The artificial intelligence in our application, for example, is not a black box. It will not be so directive. This will be really, we make this comparison with this, the GPS that we are using every day. Whenever you go somewhere, you are programming your destination, and sometimes you never know where to go. But the idea is a little bit the same. At some point, you can discover from this AI different routes, different strategy. You can discover different means. It's proposals that are made to the end users, and it's really this is exactly what we want the AI to be for machining offers. Really to be able to guide the user and to propose alternatives that are making sense for the users, based, of course, on the experience of hopefully in the future we will be able to really leverage the knowledge from this technology, the knowledge that has been stored or that has been created along the long time, programming of the different past parts and operations made on the machines. So that's really the way we think artificial intelligence should be implemented or used, in the CAM environment that we have in our application. As an example, as an example here, one of the first capabilities that we're providing is really to support the ramp up of new users. Proposing, as I was saying, our application today, and I think it's not necessarily specific to ours. I think most of the tools on the market today are quite complete with a lot of capabilities, different, many types of toolpaths available. And the idea here is really to guide the user to select the appropriate toolpath type for him. Give him the choice, of course. So it's, again, still open for the user to make the last decision. But whenever you're machining a simple hole, you get access to the exact operations that are relevant for a simple hole. If you are selecting a pocket, you get the exact different type of operations that are relevant for pockets. So that's the idea of this one. I can show you within a short video what does it mean.
So this AI-based capability is really to help less experienced users with the creation of operations. One of the difficulty today is that our applications are more and more rich with different type of toolpaths that are available to do the job. So for new users, it's really sometimes a difficulty to find the appropriate and the relevant operation for a given programming. So what we are proposing here is that the system will support with predictive operation the capability to select, to pre-select, let's say, the toolpath type. So the user is selecting a geometry. Based on this geometry, the system is proposing the most relevant type of operation for him to select. No need to look for a complex one, to question him about the relevance of the operation. Every selection is proposing the appropriate sequence, even for simple operations for drilling. There are still many options that can be displayed. From that, it can then work in the creation of the different parameters and create the.
So as a recap on this one, what you have seen is really the simplification in the user interface that I think we can expect together with this AI-based capability to really propose the users the appropriate toolpath in this complete set of applications and toolpath that we have in the application. Next, whenever we use this the AI to support new users ramp up, it's the possibility now that we have to propose alternative parameters. The idea is that the user is selecting first, is creating his own toolpath, is selecting the appropriate parameters based on his experience or based on his knowledge. And from that, the system will gonna propose him the possibility, the extra capability to suggest additional toolpath types, toolpath parameters, changing the parameters based on some trained data. And from there, we can optimize at some point. We can explore again, as we can use this metaphor of the GPS, the different possibilities to provide him more performance, let's say, on the machine. And I think we can see that in the next video.
So one of the first AI-based optimization is for the machining time. Based on an existing toolpath, the operator can ask the system to propose some alternative parameters for the toolpath. Based on that, the AI will make a calculation in the background, proposing suggestions on the different alternative with the key parameters. Of course, one of the key ones is the machining time, but also, you know, you get the diameter ratio, the depth of cut, and all that kind of important parameters, which allow the user to select from the machine time perspective, but also from the cutting tool life perspective. And once you know, he's selecting one of the options, he can automatically replace in his programming sequence.
All right. Last but not least, the knowledge capitalization. Really to maintain future machining performance, I think it's important, you know, also to have this capitalization on the knowledge, being able to have some kind of a template program that can be associated to geometry, and really creating very quickly complex programs based on past experiences. And I think we'll come on that, but really after that, it's about, whenever you reuse the knowledge, it's about recognition of the geometry. And this is where the challenge is coming, because we are not only using standard features for recognition, but advanced user-based feature. And this is really where we can go up to automate based on the knowledge of the company and the expertise of the people of the company in their programming activity. So let's have a look to what we can propose there.
So to drive the transfer of expertise from expert users to new users, knowledge management is really key. Through the means of feature recognition, it can be easily applied to new geometry. The creation of the operation based on the knowledge of the expert is automatically created, ensuring the new user to create efficient toolpath very quickly. For quite complex geometry. So it's really important, this knowledge management, to be taken into account in this transition from experts to new users.
So as you can see, it's quite quick, and this knowledge capitalization is key for me for the future of the automation, and artificial intelligence will really play a key role also in this area, and we'll come back to that. I just want to give you some highlights on the before we go to the question and answers on our capability. What are the tools? What our DELMIA machining solution is bringing value? You know, we are part of a big organization now, Dassault Systèmes, which is long-term driven company with quite a lot of you know, more than 23,000 people in the company, and more than 350,000 customers around the world. And we are part of the, you know, the organization is spread over, and the different applications are spread over different brands, and we are part of the DELMIA for manufacturing, which is the motto is make it happen. It's really to really drive what's going on and define, execute, optimize operations on the shop floor. And as part of that, yeah, we've got a complete offering for DELMIA Machining to really propose, you know, an experience of CAM programming in a virtual workshop. The idea is really that the user is immersed into the machine itself. Is having, you know, the environment overall. Is having a set of capabilities, best-in-class tools for programming, and he can program his machine as if he were in front of the machine. We're doing that for, you know, of course, milling, and this is the historical, you know, area. But we are now targeting turning, mill turn, complex machines, but also wire EDM, and laser cutting or water jet cutting, and as well as the knowledge management and the capability to design resources, machine, cutting tools, clamping tools. So to provide, you know, one solution for all the processes in the shop floor, connected to the product design environment, if it's available. So it's really to have the continuity between CAD and programming on the shop floor. It's really key to be agile for companies. Some takeaways on this session today regarding AI and the powered machining with AI. So it's not magic, you know, but it can guide the new users. I think this is important to really keep that in mind, and the way we want to implement AI is not the technology for the technology, but really for the sake of helping the user, and combined with the company knowledge where it will really best support the NC programmers. I really think that this is where we should go. I'm not sure we're gonna have total generative machining programs right away. We need to rely on the knowledge where to be sure we can optimize the machining time and the efficiency on the shop floor based on the experience of the company and the past activities that we had. Regarding the our solution, so I've just said it, you know, we've got this capability for virtual workshop, collaboration environment to be able to share the knowledge. For example, if we have different people, if we have different location for programming, it's easy with the environment provided with the application to exchange and to share the knowledge, to have always the simulation available, being able to have this capability to simulate the toolpath right away, and advance, of course, toolpath for adaptive concentric milling, for, you know, hard material machining, as well as the support of the different machines, as I said, and the automation and the knowledge. So we are up to the almost to the end of this session.
Very good. Thank you, Dominique, for an excellent presentation. A few of our attendees have already submitted questions, and we're going to turn to those and begin to address those right away. I want to first ask each of you, please take a moment to complete the feedback form that will appear on your screen at the end of the webinar. So let's look at the questions. Dominique, if you will, tell us, what is it about feature recognition that is considered AI, artificial intelligence?
Oh yeah, I think this is an important point, because feature recognition is quite known in this domain of CAM programming. You know, trying to find out holes or pockets is quite an easy stuff, and it's not artificial intelligence per se. And this is used also, you know, to reapply knowledgeware, as we said, for example, a template of programs on top of a regular feature. But you know, I want to just differentiate a little bit what we're talking about here, because in our application we are not only recognizing, you know, standard features like holes, pockets, or such kind of stuff, faces, but user feature. And for user feature, if you rely only on the topology, which is what usually CAM software are doing, you will not be able to recognize all the geometries, similar geometries, and totally reapply the knowledge warehouse. So this is where the artificial intelligence will play a role in the near future, and this is where it's important to have this in mind for for this feature recognition consideration in regards to AI. So some may say, no, it's not AI. Yes, for sure. But if you are considering user feature recognition, at some point you will need these AI capabilities. This is the point.
Very good. On which database is the AI being trained?
Yeah, that's a good question also about how do the training on the models. Today, we are using some kind of a synthetic data based on the experience that we have across different customers. But in the future, of course, this will need to be applied on the on customer data, so that we can really leverage the expertise of the users and the past experience to provide support with this artificial intelligence, for sure. That's for sure. And we have, as we have this environment in our 3D experience platform, the data are stored. I think this is a good way, most probably, to really leverage those data from the customer.
Excellent. What future trends or impacts do you expect from AI on machining activity?
Yeah. There will be many. We've seen already a few things. This is really the beginning. You understand that I talked about first in the first question about the feature recognition. That would be most probably something where AI will bring value. Also most probably also in the knowledge capitalization one day, we'll probably be able to complete one of the order of this knowledge creation is the time for knowledge creation. That could be a difficulty so far. This is what we see at customers. Even though it brings value, it should be an investment. So maybe in the future, AI will bring that, and most probably the assistance overall to the user will be totally enhanced, but fitting exactly the needs. And this is really the point, to really have proposals to really help the user to be efficient in his environment, not in the global environment. I think that's where AI will bring value to CAM programming, and the automation of the programming could be one of the consequences.
An excellent point. It has to have personal value for the users to gain their satisfaction from the employment of it. Well, that brings us to the end of our presentation today. I want to thank our speaker, Dominique GALMEL, for excellent insight and sharing his knowledge. And I want to thank our sponsor, DELMIA Machining. On behalf of American Machinists, have a great remainder to the day.
Thank you. Bye-bye.